We will start. In the last lecture, we have started new chapter about pavements, different types of pavements, then how to design the pavements that we are going to learn in this chapter. Okay. So whatever the basic things regarding the design of the pavement or the introductory part of the pavement that we have covered in the last lecture. Now we will move forward for the design of the flexible pavement and the rigid pavements. What are the different steps or required for the design of the different kinds of the pavements? Okay. So before designing, we will see briefly. We have also seen in the last lecture the difference between the flexible and the rigid pavements. So the pavement design, it is based on the structural behavior. Pavements are generally classified into the two types, that is flexible pavement and the rigid pavement. Okay. So in the flexible pavement, you can see here, they have given or shown, it is shown here that different grades, different layers of the that is first one is the subgrade, then the subbase, base, binder material may be there, and the surface coat will be there. Okay, so this is what the layers present into the flexible pavements. Then in the rigid pavement, there will be only one layer PCC and the base coat. Okay, these two layers only are there into the PCC. So the next thing is that, so see here, these are asked 2 times in the exam. Okay, this is asked 2 times. They have shown the shape, the different layers of the pavement, and they have asked whether it is flexible pavement or the rigid pavement. So you should also know the different layers of the respective pavements, flexible pavements and as well as for the rigid pavements. Then what is the IS or the IRC, that is Indian Road Congress, that is used for the design of the flexible pavement and the design of the rigid pavement. So for designing flexible pavement, we are using the IRC 37-2001. It's very important. And for designing the rigid pavement, we are using IRC 58-2002. These are very important. You should know. Please remember this. Then whatever the load that is transferred by the flexible pavement, it is grain to grain contact. Okay, whatever the load is transferred by the grain to grain contact, and in the rigid pavement, load is transferred uniformly by the slab level. Then the stability depend on the aggregate interlocking, partial friction, and the cohesion. As the load is transferred by the near grain to grain, so the interlocking between that grain is very important, as well as the partial friction between them and the cohesion between the different materials in the flexible pavement. It is very important. And here the structural capacity is supplied by the pavement slab only. How the load is transferred by the pavement slab, and in that by the beam action. Okay, one beam or one slab will be there, and it will transfer whole load to the subgrade. So there will be the beam action. Then the pavement design is greatly influenced by the subgrade strength. Okay, the subgrade strength is very important in the pavement design whenever we are designing the flexible pavement. But the subflexural strength of the concrete is major factor for the designing the rigid pavement. Okay, the flexural strength of that slab that we have provided by the concrete, that is very important into the rigid pavements. Then the design life for the expressway, it is 20 years. National and state highway, it is 15 years. And other roads, it is 10 to 15 years. This is for the flexible pavement. This is very important factor. And in the rigid pavement, the design life will be considered as for highly volume traffic road, 30 years, and low volume traffic roads, 20 years. Okay, this also you should know. For the rigid pavement, approximately 30 years lifespan will be there. And for flexible, it is depends on the expressway, it is 20, national highway, it is 15, for other road, it is 10 to 15. Okay, so likewise the life period of the pavement will be there. So this is what the difference between the flexible and the rigid pavement. This is very important difference. Then the anticipated traffic, we have to judge or we have to think about the traffic that will be come, because the traffic is very important whenever we are designing the pavement. The life period of the pavement, the design characteristics, thickness, all these things are depends on the traffic conditions. So we have to judge the traffic before we are going to design. Okay. So for anticipated traffic, to calculate the design traffic intensity, the number of commercial vehicles per day means what? How much number of vehicles that are traveling on that road per day. It is calculated by using the formula A is equal to P into bracket I plus R raised to X, where A is what? Design traffic intensity, that is number of vehicles, commercial vehicles that are passing per day. Then the P is the number of commercial vehicles per day at last count. Then the R is the rate of growth of traffic. X is the number of years between the last count to the till date. Means what? It is the period of calculation. Okay. So whenever if the data of the annual growth rate of commercial vehicle is not available, or if it is less than 5%, then whatever the growth rate, okay, the growth rate data, if we don't have it is not available with us, then it is generally taken as 5%. Okay, the growth rate is taken as 5% as per the IRC 84/2007. Okay, and when we are designing, for design it is taken as 7% is considered. Okay, the general growth rate is considered as 5%, and whenever we are designing, for design it is taken as 7% as per the IS 84/2007. Okay, IRC. Then the design traffic. The design traffic is what? The design traffic is based on the 7-day, 24 hours traffic count as per the IRC 9. Okay. How we take the design traffic? We have to calculate the number of vehicles, commercial vehicles that are traveling on that road for 7 days, 24 hours. Okay. Then that traffic count is taken as for the design traffic. This is given as per the IRC 9. Then what is the maximum wheel load? Okay, maximum wheel load means what? The total load influenced by the thickness requirement of the pavement. Okay, the total load influences the thickness requirement for the pavement. Okay, because depending on the load that is transferred by the wheel, the thickness of the pavement is decided. So to decide the thickness of pavement, what is influence? The influence is what? The wheel load. Okay, so whatever the total load of the wheel that is coming on the pavement, it influences the thickness of the pavement it is required to be designed. Okay, so we need to calculate the maximum load first. Then tire pressure influences the quality of tire pressure. It is influences the quality of surface force. Okay, how should be the surface force? It is influences by the tire pressure. Okay, tire pressure is greatly affected by on the surface forces. And whenever we are designing the pavement, it is based on the 98th percentile axle load. Okay, we will calculate the different axle loads for the different commercial vehicles. We will take the cumulative of that, and after taking the cumulative, we are designing that road for the 98th percentile axle load. Okay, then what is meant by the contact pressure? Contact pressure is nothing but the ratio of wheel load to the contact area. Okay, wheel load that is transferred on the pavement divided by how much contact area to transfer that load. Okay, load divided by area, that will give us the contact pressure. So the contact pressure or the tire pressure will be generally taken as 5 to 7 kg per centimeter square, and for design it is taken as 7 kg per centimeter square. Then what is the rigidity factor? Rigidity factor is nothing but the contact pressure divided by tire pressure. Okay, what is meant by the rigidity factor? It is contact pressure divided by tire pressure. And if it is equal to 1, what will it indicates? The tire pressure is equal to contact pressure. Then the contact pressure for design we are taking 7 kg. Means what? See here. For design what we are taking? The contact pressure as 7 kg per centimeter square. Suppose if the tire pressure, as we know the contact pressure is 7. Suppose if the tire pressure is also 7, then what will happen? This will become as ratio will become 1. Means what? When the ratio it is 1, it indicates what? Rigidity factor. The tire pressure is also 7. Okay. When this rigidity factor is less than 1, when this rigidity factor it is less than 1, see here, if this ratio will be less than 1, then what will happen? This is whatever the denominator will be there, it is greater than 7. It will be 8, 9, 10. Okay. So when this ratio is less than 1, it indicates the tire pressure is greater than 7. Okay. When this ratio is greater than 1, it indicates tire pressure is less than 7. Okay. So this is very important. The rigidity factor, how to calculate the rigidity factor? It is the ratio of contact pressure to the tire pressure. And contact pressure we are generally taken as 7 kg per centimeter square. Unit, please keep in mind, the unit is kg per centimeter square. Contact pressure is equal to 7 kg per centimeter square. It is taken as generally for design, and the rigidity factor calculated as contact pressure divided by tire pressure. So depending on the rigidity factor, if it is 1, tire pressure is 7. If it is less than 1, tire pressure is greater than 7. If it is greater than 1, tire pressure is less than 7. According to these two constraints will be varies. Okay. In the design rigidity purement, as per the IRC 58, the tire pressure for the design it is taken as 0.8 MPa, that is 8 kg per centimeter square. Okay. As we are taking the contact pressure as 7 kg per centimeter square for design, likewise, whenever we are designing the purement, as per the IRC 58, the tire pressure it is taken as 8 kg per centimeter square. When we put this tire pressure as 8 kg, what will happen? The ratio will become 7 by 8. So it is always less than 1. So whenever we are designing the purement, the rigidity factor is taken as less than 1. We can say by this. Okay. So graphically, it is shown here how the single load, fill load will be there, how the equivalent single load will be there. Okay. So see here. So these are the two wheels. You can see into the figure. This shown here. So these are two wheels. Okay. Whenever the load that is coming from the vehicle, that is equally distributed on these two wheels. Okay. Up to the depth d by 2, what is d? This is the distance between two tires. Okay. What is d? The distance between two tires. It is shown here. See. Small d, it is the distance between two tires. When I will go up to the depth d by 2, okay, up to the depth d by 2, the pressure will be same as P. See here, the pressure distribution is shown here. And as I go deep, the pressure will goes on continuously increasing. Okay, as I go into the deep, the pressure will continuously go on increasing. Then at the distance 2s, the pressure will become as 2p. Okay. At the distance 2s, pressure will become 2p. See here, I will explain once again. Please see the figure. The clear distance between two tires is d. The clear distance into in. See in the figure. In to in distance between the tire is d. And the center to center distance between the tire is s. Okay, center to center distance between the tire is yes. So When I go up to the depth of d by 2, the pressure will be as p only. Okay. When I will go up to the depth of d by 2, the pressure will be as p. When I will go up to the depth of 2s, okay, when I go up to the depth of 2s, then the pressure will be equal to 2p. Okay, please remember these values only. For depth up to d by 2, pressure is p. And for depth of at 2s, the pressure is 2p. Okay, between them, p to 2p, it will varies linearly. Okay, so see here it is given here. Up to d by 2, each wheel load p acting independently. After 2 years, single wheel load 2p it is active. Okay. Then in between d by 2 and 2 years means what? This much area. In between this area, the load acts from p to 2p. It will increases from p linearly towards 2p. Okay. At d by 2 it is p. At 2 years it is 2p. From d by 2 up to 2 years it will increase as p to 2p. Okay. So as per the IRC, maximum equivalent single load it is taken as 4080 kg. This is very, very important. Star mark, it is important value. Please note this value. Please note this value. As per the IRC, maximum equivalent single wheel load, 4080 kg. It is asked in the previous year question papers. 4080 kg. And as per the IRC 37/2001, standard load for the single axle with the dual wheel. If there will be the dual wheel, then on either side the load is taken as 8170. Dual wheel means what? Two wheels are there, then axle will be there, then two wheels will be there. Okay. If such condition will be there, then the equivalent single wheel load taken as 8170 kg. Okay. Near about 800,000. Near about 8,000 kg. Please note, write down these notes. Write down this as per the IRC. The equivalent single load is 4080 kg. Write down these values. These are very important values. 4080 kg. Then write down the below also. As per the IRC 37/2001, standard load for the single axle with the dual wheels on the either side 8170 kg, and as per the IRC 37/2002, it is approximately 8000 kg. Write down these values. Write down these values. Is it over? Okay. We will move forward. Those who have not completed, take the screenshot. Okay, then we will see now the flexible pavement design. Okay, now we will see the flexible pavement design. What are the different methods of the flexible pavement design? That are, the first one is the theoretical, second is the semi-empirical or the semi-theoretical method, and third one is the empirical method. Okay, so these three are the methods to design the flexible pavement. In the theoretical method is the Burmester method. Please keep in mind the names, at least you should know the names of each and every method. Okay, so in the theoretical method, the Burmester method is used. In the semi-empirical or the semi-theoretical method, triaxial test method modified by the Kansas State Highway Department. Okay, the triaxial test that is method is used as the semi-empirical or the semi-theoretical. Then the empirical method is based on the physical properties or the strength of the pavement of the subsoil grades. And the different methods are GI method, CBR method, stabilitometer, and the MC load method. Okay, so these are the different methods of designing the flexible pavement. In that, we will see the first and very simple method, that is CBR design method. Okay, CBR method is very simple and mostly used for the design of flexible pavement. In the CBR method, the material with the given grade of CBR requires a certain thickness of pavement layer as a cover. Higher the road, the higher the thickness of the pavement. Okay, so it is depends on the traffic density, the materials or the grade of the pavement it is required depends on the traffic condition. As the it is higher the traffic condition will be there, the higher will be the thickness of the pavement that is required. Then the thickness of the subbase and the thickness of the base. It is we can simply judge by the layers, as we know. If suppose this is the total thickness, this is the subbase, and this is base. Okay, then how does we calculate the subbase thickness? The total thickness minus the thickness over the base. Okay, so that by this we can calculate the thickness of subbase, and the thickness of base, thickness over the subbase minus thickness over the base. Okay, this is very simple formula by the figure that you have drawn. Okay, the figure that you have drawn, that figure, by that figure you can simply judge this. Then what are the IRC recommendation for the design of the flexible pavement as per the CBR method? So CBR test, it is very important. Please see here, CBR test performed in the laboratory. Okay, please keep in mind CBR test is performed in the laboratory. In situ tests are not recommended as per the IRC. Okay, for new road compacted to the OMC. This is very important. Please everybody keep in mind. For new road, the CBR test for it is compacted up to the OMC. What is OMC? OMC means what? Optimum moisture content. Optimum moisture content. That is OMC. So, as per the IRC, the new, if we are constructing the new road, it is compacted up to the OMC. And if it is the existing road and we have to perform the CBR test on that road, we have to compare it up to the FMC. FMC is what? Field moisture content. Okay. So, and whenever we are performing this CBR test, we have to ensure that 4 days soaking of the sample should be there. Okay. The sample is soaked for 4 days in the CBR test, and we have to give minimum 3 samples. Okay. We have to test minimum 3 samples. Top of 50 centimeter of the subgrade is compacted up to the 95 to 100% of the Proctor density. Okay. How much density we will achieve at the top? 95 to 100% density. Major roads are designed for 10 years and the minor roads are designed for the 5 years. Please keep in mind, in the flexible pavement, as per the CBR method, the major roads are designed for 10 years and the minor roads are designed for the 5 years. Okay. Thin layer of the wearing core shall not be treated as the crust. Okay. Thin layer of wearing core shall not be treated as the crust. We have to go for the more layer. Okay. Then, as per the modified CBR test, it is taken as per IRC 37/2012. This is very important. IRC 37/2012. It is used for the CBR method, that is flexible pavement study. So, as per the CBR percentage increases, the required thickness of the pavement decreases. The design, it is based on the cumulative number of the standard axles. So see here, what is the formula for modified CBR test? H is equal to square root of P into bracket 1.75 divided by CBR minus 1 by P pi whole raised to 1/2. That is square root of. What is P? That is wheel load in kg. P, small p. This is the small p. This is capital P. Okay. This is capital P and this is small p. Okay. Small p is the contact pressure in kg per centimeter square. H is the thickness of pavement that is required. Okay. So see, by this formula, we can say as the CBR, it is in the denominator. Thickness H is inversely proportional to the CBR. Means what? Thickness H increases as the CBR decreases. Okay. And as the CBR increases, required thickness of the pavement will be decreases. Okay. Vice versa, we can say by the formula. So cumulative number of axle, how we can calculate? N is equal to 365 into bracket 1 plus R raised to N minus 1 divided by R into A into D into F. So this is the formula for calculating the cumulative number of axles. Okay, how much number of axles are provided, and it is measured in the MSA. Sorry, MSA is nothing but million standard axle. This is the unit of cumulative number of axle. Okay, this is the unit of N. Unit of N. What is the unit of cumulative number of axles? Million standard axle, that is MSA. Okay. So this is the formula for calculating the cumulative number axle and the thickness of the pavement as per the IRC. Please write down this formula. Please write down this formula. As per the modified CBR test. As per the modified CBR test. As per the modified CBR test. Thickness of pavement in centimeter. Thickness of pavement in centimeter. Thickness of pavement in centimeter is equal to below that write down this formula. H is equal to square root of P into bracket 1.75 divided by CBR minus 1 by small p into pi whole bracket complete raised to 1 by 2 bracket raised to 1 by 2. Right down below P is the where P is the field load in kg. P is the field load in kg. Small p is the contact pressure in kg per centimeter square. Contact pressure is in kg per centimeter square. Small h is equal to thickness of pavement in centimeter. Below that, write out cumulative number of axles is equal to cumulative number of axles is equal to. This can be also asked for MCQ as well as for the numerical. N is equal to 365. N is equal to 365 into bracket 1 plus r raised to n 1 plus r raised to n minus 1 divided by r minus 1 divided by r into a into d into f. A into d into f. Below that, write down unit of n is small msa, that is million standard axle. Million standard axle. Right down below that, where a is equal to write down this, where a is equal to initial traffic in the year of initial traffic in the year of completion of construction of road. Completion of construction of road in vehicle per day. In vehicle per day, R is equal to annual rate of growth of traffic. Annual rate of growth of traffic n is equal to design life in year. N is equal to design life in year capital D is equal to lane distribution factor in bracket LF LDF capital F is equal to vehicle damage factors, that is VDF, vehicle damage factor in bracket VDF. These are the constants that are multiplying constant used in this formula, that is lane distribution factor and the vehicle damage factor. Okay, below that, write down lane distribution factors. Okay, what is the lane distribution factor? Write down the table, how much it is taken. Write down the table, make 2 columns. In the first column, type of a traffic, and in second column, LDF, that is lane distribution factor. Write down this column and write down this table. Everyone, please write down this table. It is very important. So this is the constant, that is LDF, lane distribution factor, and the values of lane distribution factors that are taken, that are given here. For the single lane road, it is 1. If there is a 2-lane single carriage load, 0.5. For the 4-lane but the single carriage road, 0.4. If there is a dual carriage road and 2-lane, 0.75. Dual carriage road and 3-lane, 0.6. Dual carriage way and 4-lane, it is 0.45. Okay, these are the LDF, that is lane and distribution factor for the various type of traffic roads. Then the vehicle damage factor, right on the second table. Vehicle damage factor. Vehicle damage factor. Vehicle damage factor, it is depends on what the commercial vehicles per day. Okay, how much commercial vehicles are there per day? It depends on that. And what is mean by the commercial vehicle? That are the heavy loaded vehicles whose weight is more, the vehicles which are designed for carrying the load more than 3 tons that are categorized into the commercial vehicles. Loading weight, if the vehicle has the loading weight greater than 3 tons, then that vehicles are considered as the commercial vehicles. Okay. CV means what? Commercial vehicle. And depends on the commercial vehicles passing from that road per day, the vehicle damage factor varies. And also depends on the terrain condition, whether it is rolling or plain terrain and the hilly terrain is there. So make 3 columns. The first column, initial traffic in terms of the CV per day. CV means commercial vehicles. If you want to remember, write down there, CV is equal to commercial vehicle. And in next column, write down terrain. In that, make 2 columns, rolling or plain and hilly. These are very important factors. It requires whenever we are designing the feasible project. Initial traffic in terms of the commercial vehicles per day. If the traffic is in between 0 to 150, then 150 to 1,500 and greater than 1,500. For 0 to 150, rolling or plain terrain, the VDF is 1.5. For hilly, it is 0.5. When the CV per day is 150 to 1,500, for rolling or the plain terrain, it is 3.5, and for hilly terrain, it is 1.5. If the traffic is greater than 1,500 CV per day, that is commercial vehicles per day, then for the rolling terrain, it is taken as 4.5. For the hilly terrain, the VDF, that is vehicle damage factor, it is taken as 2.5. These are very important terms. And also when the traffic is from the both direction, then at that time the traffic in the one direction, it is considered as a half of the traffic. It is in the both direction. If the traffic it is given as in both the direction, then in the half one direction, it is taken as generally half of the traffic which is moving into the both direction. Okay. Then below that, as we have discussed in the last lecture, the sample size for the axle load survey, how much it is. What is meant by the sample size? Okay, whenever we are designing the road for the CV, that is commercial vehicles, also we need to check whether these commercial vehicles are traveling with their specified defined loading. Okay, because as per the government criteria, for the different kind of the vehicle, different loading limits are prescribed. Okay, we have to check the random commercial vehicles whether they are traveling with their given required norms. Okay, for the loading, because it will travel with the higher loading that are designed more than design, then what will happen? Our design calculation will get failed. Okay, so we need to carry out the survey for the sample size for the axial loads. And in this survey, how much vehicles to be tested or the how much vehicles to be checked whenever we are designing this or we are performing this survey. Then for if the commercial vehicles passing by that road are less than 3,000 per day. Okay, what I am saying, if the commercial vehicles traveling from that road are less than 3,000 per day, then at that time we have to check the 20% of the commercial vehicles. Okay, we have to check the 20% of commercial vehicles. If the commercial vehicles passing from that road are 3,000 to 6,000 vehicles per day, then at that time, what we'll have to do, we have to check the 15% of the commercial vehicles. And if it goes above the 6,000 commercial vehicles per day, then at that time we need to check at least 10% of the commercial vehicles. Okay, for whether we have to check whether that vehicles are traveling with their specified limiting loading conditions. Okay, please write down this table also. This is very important. It is this table is given as per the IRC 37/2012. That is for the flexible pay. Write down this table as well. Write down next table. Sample size for the axle load survey. Sample size for axle load survey in the bracket as per the IRC 37/2012. IRC 37/2012. Below that, write down total number, make two columns. Total number of CV per day, that is commercial vehicles per day. And into the second column, in the second column, minimum percentage of commercial traffic to be surveyed. Minimum percentage of commercial traffic to be surveyed. Write down this table. If the CV per day is less than 3,000, minimum percentage of commercial traffic to be tested is to be surveyed is 20%. Minimum we need to check 20% CV commercial vehicles. Okay. If it is 3,000 to 6,000, then we need to check minimum 15% vehicles. And if the traffic is greater than 6,000, we need to check at least 10% of the commercial vehicles. Write on this table. Okay, so the next term is what is meant by the equivalent factor. The next term is the equivalent factor. What is the equivalent factor? Equivalent factor is nothing but to evaluate how much will be the damaging factor. How much will be the damaging factor for the different axle loads. To evaluate how much will be the damaging factor for the different axle loads with respect to the standard load. Okay, and how it is calculated? The equivalent factor is equal to axle load divided by standard axle load. Okay, and whole bracket raised to 4. So how to calculate the equivalent load factor? Equivalence factor is equal to actual axle load divided by standard axle load whole bracket raised to 4. So this is the formula to calculate the equivalency factor. Okay. Then the next term is the subgrade. Okay. What is the subgrade and how the subgrade should be prepared in the flexible pavement as per the CBR test. Okay. In the flexible pavement, how the subgrade should be prepared. Okay. So for the expressways, national highways, state highways, major district roads should be compacted to the 97% of the dry density with the heavy compaction, that is modified Proctor compaction. Other cases, 97% dry density of the standard Proctor compaction. Okay, as we know, there are two different methods of the compaction: standard Proctor test and modified Proctor test. Okay, whenever we are compacting the subgrade layer for the national highways, expressways, state highways, for such roads, we have to ensure that 97% of the dry density with the modified Proctor test. Okay. And whenever we are dealing with the other roads, that is village roads, minor district roads, okay, for such cases or other district road, for such cases, we have to ensure the 90% of dry density by the standard Proctor test. Okay. So for the expressways or the national highway, state highway, major district roads, subgrade material should have the dry density of less than 1.75 gram per cc. Okay, whenever we are taking the subgrade, we should have to ensure the dry density should be less than 1.75 gram per cc. Okay. Cc means what? Cubic centimeter. 1.75 gram per cubic centimeter. The dry density should be less than 1.75 gram per cc. Okay. The CBR sample should be soaked for the 4 days. Okay, that we have seen. We have taken the CBR sample. We have to take at least 3 samples and we have to soak it for the 4 days. Okay. Then CBR value should be based on the remolded soil tested in the lab only. Please keep in mind, CBR test is the laboratory test. Okay. Whenever we are doing the CBR test, we have to do into the lab only, and we have to take the soil which is remolded. Okay. Then the preferably by the static compaction. We have to go with the static compaction. No need to go for the dynamic compaction. Then minimum 3 samples have to be tested, and the maximum variation is shown below. Okay. Minimum we have to prepare the 3 samples. We have to take or bring that samples. We have to keep the CBR, we have to perform the CBR test into the lab by the static compaction on the remolded soil. Then we have to soak this sample for the 4 days and we have to achieve the dry density less than 1.75. Then after that, we need to calculate the CBR percentage. We have seen also the test, how to perform the CBR test. Then by this, whatever the amount of CBR percentage that we have achieved, how much will be the maximum variation is allowed there. Okay, on C2. How much the maximum variation allowed there? If the CBR percentage is 5%, then the maximum variation is allowed as 1 plus or minus 1. If the CBR percentage is from 5 to 10, maximum variation is allowed as 2. If the CBR percentage from 11 to 30, then the maximum variation of the CBR value is allowed plus or minus 3. Means you can go plus 3 or minus 3. And if it is greater than 31 CBR percentage, we have to go with the maximum variation of plus or minus 5. And if suppose this maximum variation is not achieved, we have gone beyond that. Then what happen? Then if this variation is more than these values, then what we have to do? We have to take the 6 samples. Okay. Initially, what we have done, we have chosen 3 samples or we have tested 3 samples. But if the variation of the CBR value goes beyond the values given in this table, then at this time we need to take 6 samples for the test. Okay. So this is about the CBR method for calculating the thickness of the pavement for flexible pavement. Okay. Write down this table as well. Maximum variation of the CBR values. Maximum variation of the CBR values. Write down this table as well. It is important. Make 2 columns. In the first column, CBR percentage, and in the second column, maximum variation. Okay, so we'll move forward. Now we will see the rigid pavement design. Up till what? Up till now, what we have seen the flexible pavement design. Now we will see the rigid pavement design. In this, we need to understand first the modulus of the subgrade reaction, and that we have discussed earlier as well. What is the modulus of the subgrade reaction? K. Okay, modulus of a subgrade reaction is K. And how does we calculate the K? It is nothing but what? Modulus of subgrade reaction. When we are going to increase in the pressure, whatever the deflection that we will get for that pressure, it is calculated by the ratio of this. It is known as modulus of subgrade reaction. Means what? It is nothing but the pressure divided by the deflection. Okay, so the modulus of subgrade reaction is equal to P by delta. This we have seen before as well, and this delta displacement, it is taken as 0.125 centimeter. Okay, this displacement is taken as 0.125 centimeter, that is 1.25 0.125 centimeter, 1.25 mm. Okay, this is delta is taken as means pressure it is increases, and we need to stop the pressure increasing at the deflection of 1.25 mm. Okay, and we are testing this by the plate load test, and the standard plate size that we are using here is 75 by 75 centimeter to perform this test. Okay, so how does we calculate the modulus of the subgrade reaction? That is when we are taking the it is calculated by using the plate load test. Okay, and we are keeping this plate on the ground, then we apply the load on that, then by the load it will gives us the deflection, then we will stop at the deflection of 1.25 mm. Then at that time whatever the pressure will be there, pressure divided by that deflection, it will give us the subgrade reaction, that is K is equal to P by delta. By using this formula we will get the modulus of subgrade reaction that we have already seen. Then the relative stiffness of the slab to the subgrade. What is meant by the relative stiffness? See here, a certain degree of resistance to the slab deflection is offered by the subgrade. Okay, what will happen? The slab will go on deflecting. Then what will happen? Whatever the subgrade soil will be there below that, it will offer the resistance for the deflection. Okay, and the subgrade deformation is the same as the slab deflection. Hence, the slab deflection is the directly measurement of the magnitude of the subgrade pressure. This pressure deformation characteristics of the rigid pavement lead Westergaard to define the term radius of relative stiffness L in a centimeter is given by the equation below. Okay, means what? How the radius of the stiffness it is given, because where the load is applied on the pavement, along with the pavement, what will happen? Whatever the subgrade soil will be there below that, it will also tries to deflect, because it will use the offer the resistance to deflection. With the pavement, the soil will also go on deflecting. By this, they have formed one new relation, that is relative stiffness, new term, and by the Westergaard, the relative stiffness it is given as, see this formula, L is equal to please write down this formula, relative stiffness is equal to, write down this formula, relative stiffness is equal to L is equal to fourth root of EH cube divided by 12K into bracket 1 minus mu square. You can also write like this, EH cube. Everyone please write down this formula, 12K into bracket 1 minus mu square whole bracket raised to 1 by 4. You can write any of this way. You have both ways to write. You can make fourth square root of 1 by 4. You can write in these both ways. EH cube divided by 12K into bracket 1 minus mu square H is the thickness of pavement, E is the modulus of elasticity, K is the modulus of subgrade reaction, mu is the what? Poisson's ratio. By this we will calculate the L, small l, that is relative stiffness. Okay. Write down this formula for the relative stiffness. L is equal to fourth root of EH cube divided by whole K into bracket 1 minus square bracket complete. Then also they have given one new formula, that is the radius, equivalent radius of the resisting section. Means what? When the interior point is loaded only by the small area. Okay, whenever we are uh, giving the load by the weight to the pavement, it is given on the small area of the pavement. Okay, is rising the bending moment of the plane. Okay, whenever we are giving the load on the plate on the small area of the pavement, then what will happen? It will resisting the bending moment of the plate. Okay, then by this the Westergaard gives the relation for the equivalent radius of the resisting section in the centimeter in the below equation, where A is the radius of the wheel load distribution in centimeter and H is the slab thickness in the centimeter. So the Westergaard has given the formula for calculating the radius of resisting section. Okay, and how does he calculate? B is equal to 1.6 a square plus h square square root of minus 0.675 h if the A is less than 1.724 h. If A is greater than this term, then B is equal to A. Okay, so this is the formula for calculating the radius of resisting section given by the Westergaard. Then we need to understand what the critical positions of the load. Okay, when the load is applied on the pavement, then at that time, what are the critical positions? Critical positions means what? On which part of the pavement, if we apply the load, then due to that load, what are the effects that are generated on the pavement? So we have to highlight that parts. So what are these critical positions of the loading? The first one is the interior, as see here, it is shown here, interior part. Then at the edge and at the corner. Okay, what are the critical positions? You can see here, please. One is at the, see here, it is at the interior portion. The another one it is at the edge, and another one is at the corner. Please write down this critical load positions. Draw this figure. Critical load position. This is interior, edge, and the corner. You can draw this figure. Interior, edge, and the corner. Okay, so these are the critical positions of the loads. Critical positions means what? Whenever the vehicle, heavy loaded vehicle is traveling on that road, what will happen? The on some certain areas, what will happen if the tire will go? It will give us the maximum deflection. Okay, so that positions that we consider as critical positions for the loading. And what are these? Interior, edge, and the corner. You can see in the diagram interior position, edge position, and the corner position. Okay, so these are considered as a critical loading positions for the roads. Then wheel load stress given by the Westergaard stress equation. The cement concrete slab is assumed to be the homogeneous and to have the uniform elastic properties with the vertical subgrade reaction being proportional to the deflection. Okay, what we have, the Westergaard has assumed the cement concrete road with it is homogeneous structure. Okay, and it has the uniform elastic property. Whenever it is given the vertical load by the wheel loads, it has uniform elastic property and the vertical subgrade reaction is proportional to the deflection. Okay, vertical subgrade reaction, whatever will be there, that is K. It is proportional to the deflection. Okay. Then the Westergaard has developed the equation for the solution of the load stress at a three criterial region of the slab, that is interior, corner, and the edges. Interior load in the interior and away from all the edges. Load applied on the edges away from the corners. Means what? Whenever we are considering the interior, it should be at the interior. It is away from the edges. Okay. When we are considering load at edges, it should be away from the corner. Okay. And when we are considering the load at the corner, it should be at exact corner, which is bisecting the both the edges. Okay. So according to that, the Westergaard has developed the relationship between the stress at the interior edges and the corner region. Okay. And he has given the formulae accordingly for the interior edge and corner places. For interior, 0.316 P upon H square into bracket 4 log to the base 10 L by B plus 1.069. Then for edges, 0.572 P upon H square into bracket 4 log to the base 10 L by B plus 0.359. And for the corner places, they have given, the Westergaard has given the stress relationship as 3P upon H square into bracket 1 minus A square root of T upon L raised to 0.6. Okay, so these are the formulas that have developed or designed by the Westergaard for the interior, edge, and the corner positions. Okay. Then what are the temperature stresses? Okay, when there is a variation in the temperature in that region particularly, then what will happen? Due to the temperature, what will happen? The concrete or any material it is there, concrete steel, it will tries to elongate. And due to the fall in the temperature, it will start to compress. Okay, so due to the this variation in the temperature by the season, what will happen? The stresses will be generated or stresses will be induced into the pavement. How we can say the temperature is affect on the pavement? For that, how does the temperature stresses affects? We'll see. Yes, we'll see now. See here. You'll better understand by the figure or video.
You got the topic down? Let's get onto it right now.
5 hours later.
Well,
हेलो गाइस, वेलकम टू यूट्यूब चैनल द सेल बंडल। आज की इस वीडियो में हम पढ़ेंगे कि जो रिजिड पेमेंट होती है उसके ऊपर लोड और जो टेम्परेचर स्ट्रेसेस की वजह से क्रिटिकल कंडीशंस किस केस में बनेगी। क्रिटिकल कंडीशन वी कैन से दैट कि किस केस में सबसे वर्स्ट कंडीशन होगी जो हमारी पेमेंट होगी उसके लिए। तो उसमें हम लोड स्ट्रेसेस पढ़ेंगे और टेम्परेचर स्ट्रेसेस पढ़ेंगे, सबको एक एक बारी से देखेंगे और एट लास्ट हम इसके अंदर ये जो हमारे पास ये टेबल है इसको हम ड्रॉ करेंगे कि जैसे एक बताऊं कि एज पे लोड कंडीशन होगी तो टॉप पे कंप्रेशन आएगी कि टेंशन आएगी, या बॉटम पे कंप्रेशन आएगी कि टेंशन आएगी। ये हम इसलिए देखेंगे क्योंकि जो हमारी रिजिड पेमेंट होती है वो कंक्रीट की बनी हुई होती है और जो कंक्रीट होती है वो टेंशन में ही फेल करती है। तो जब हम
Topic: Thermal expansion. Why are small gaps left in between rails? Don't know the answer? No worries. We shall find the solution.
Oh.
Hey, did you notice that the level of mercury in the thermometer rose when it was placed in hot water? You must be wondering why this happened, right? It happened because of thermal expansion. Thermal expansion is the tendency of matter to expand on heating. This tendency of expansion can be observed in solids, liquids, as well as gases. Now, let us see how this concept of thermal expansion applies to a thermometer. A thermometer usually consists of a narrow tube with a small bulb at its one end. The bulb and a part of the narrow tube is filled with mercury, which is liquid at room temperature. Now, when a thermometer is placed in hot water, mercury inside it expands due to thermal expansion, and as a result, its level rises.
Huh?
You must be thinking how the gasoline came out of the tank, even though it was exactly filled till the brim. Am I right? Gasoline also expands on heating. So, what happened is that when the tank was filled till the brim, there was no space left in it. Now, when the bike was kept in the sun, the tank became hot, which eventually heated the gasoline filled in it. As a result, the gasoline expanded. But since there was no space left in the tank, expansion forced gasoline to come out of the tank.
Hey! Oh yeah!
Do you think that the rails bent because of thermal expansion? If yes, then you are absolutely correct. A railway track is made up of a number of rails joined to each other. These rails are usually made up of steel. Steel expands on heating and contracts on cooling. When the rails are joined to one another without leaving any space for expansion, the rails bend due to thermal expansion and the train goes off the railway track. To avoid this, the rails are not joined together firmly. Instead, each rail is connected to the other in such a way that a small gap is left in between them. These small gaps provide space for easy expansion of the rails, which happens during summer, as well as due to continuous friction between the train wheels and the rails. Hence, these small gaps prevent the rails from bending, preventing any kind of accidents.
Okay, by this you can easily understand what is the thermal expansion, how it is affect on the different kind of the materials. Also, I have shown the example of the rails. Okay, why the joints between the rails are placed, because when the thermal expansion will be there, so it should have some space for the when it gets expand. Okay, and when it get contract, it somehow space. Okay, so the temperature stresses also affects on the different kinds of the materials, that is maybe the pavement, maybe the steel. Okay, so the temperature stresses are developed in the concrete pavement due to the variation in the slab temperature also. Okay, because there is a slab of the concrete that we have provided on the road. As we know, we provide the slab, that is a concrete layer on the road. It may have the much and more thickness. So due to what will happen, and this is the what the subgrade soil or the base. Yeah. So whatever the below temperature will be there, and what due to the heavy increase into the temperature, what will happen, the whatever the temperature at the top layer of the concrete layer, it is different than the temperature at the bottom layer. Okay, the temperature for the slab of the concrete at the top layer, it is different due to the heat of the sun. Okay, and at the bottom it is connected with the subgrade soil, so the temperature will be different. So there will be might be the changes of the temperature between the upper and bottom layer. Okay, the top layer and bottom layer are subjected to the different kind of the temperatures. So that's what will happen, the temperature stresses may be induced into the concrete layer. So this is caused by the daily variation in the resulting in the temperature gradients across the thickness of the slab, and the seasonal variation resulting in the overall change in the slab temperature. The former result in the warping stresses and the latter in the frictional stresses. So due to this variation in the temperature, what will happen? There will be the induced of the temperature stresses, that is also called as warping stresses. Okay, so the temperature stresses are divided into the two types: warping stresses and the frictional stresses. What is the warping stresses? The temperature difference between the top and the bottom surface of the concrete surface layer is a common phenomenon, whether it's a day or night. Whether it may be the day, it may be the night. What will happen? The temperature between the top layer and the bottom layer, it will have the different ranges. So what will happen due to this? The expansion and the contraction of the slab as the result of the temperature difference causing the geometric deformations, either curling up or down. Curling is what? Bending. What will happen? The slab may be bend in the upward direction or may bend into the downward direction. This is called as curling. Curling is what? Bending. So due to this temperature variation on the top and bottom layer, what will happen? The slab may be subjected to the geometric deformation, that is curling of the slab. Then the warping or the temperature stresses will produce in the slab when the geometric deformations are completely restrained by the self weight. Okay, when the geometric, whatever the deformation will be there, if the deformation will be there, then there will not be any stresses. But if we restrain that deformation, you might have heard the word restrain into the SOM, that is strength of material. Okay, I will show here by one example. See, suppose there is any subject okay, which is fixed at one end, okay, and it is free on other end. Means what? It is restrained only at the one end. Restrained means what? It is fixed and it is free at the other end. Then what I will do? I will increase the temperature. I will hit this portion. Okay, I will increase the temperature, hit this portion. So due to the heating, what will happen? The length of the member will goes on increasing. Means what? The expansion of the member will happen. The expansion of the member will take place. You might have learned this into the song, strength of material, the temperature stresses on the steel. And how does this calculated? The change in length is equal to alpha T L. Alpha, the coefficient of thermal expansion, T, rise in the temperature, L is the original length. So by this we can calculate the change in length. You might have seen this formula into the strength of material. Okay. So what will happen? The length will goes on increasing on the heating. But now what I will do, suppose this end is fixed and other end is also fixed. So what will happen in the second case? If I goes on hitting this member, it will tries to elongate, but due to the constraint on the both side, it cannot. Okay, so due to this, what will happen? The stresses, temperature stresses will be developed into that member. Also in the pavement, what will happen? The pavement will tries to elongate, but due to that self weight of that pavement, it is huge. Due to the self weight, what will happen? It will not allow to deformation. So due to this, what will happen? The stresses into the pavement also will get induced. Here the temperature stresses induced. Here the temperature stresses will not induce because it will allow us to free movement. If there is the allowance of the free movement, the stresses will not develop. If there is not allowance of the free movement, if the portion is restrained, then the stresses will develop. Okay. So the two critical conditions of the warping stresses in the cement concrete slab are presented in the figure. It is given in the next slide. Due to the curling of the slab, the tensile and the compression stresses will be developed. And it's at the bottom fiber during the day and night respectively. The maximum warping stresses is observed at the interior of the slab than the outward towards the edges, since the interior part of the slab is more restrained against the curling. As the interior part, we have seen into the figure, it is more restrained to the against the curling. So what will happen? So whatever the stresses are there, warping stresses are maximum induced at the interior portions. Okay, and how it is shown, you will see one figure. So see here, during daytime and night time, it is shown here how the tensile and compressive stresses are generated. During the daytime, at the top fiber, compression stresses are generated, and at the bottom fiber, tensile stresses are generated. Okay, and during the night time, the top fibers are subjected to the tensile stresses, and the bottom fibers are subjected to the compressive stresses. This you should know because this is asked number of times in the exams. Please draw this figure. This is very important to know. Draw this figure. This is very important. During daytime and during night time. Okay, how does the stresses are developed at the top fiber and bottom fiber? So during daytime, the compression stresses will be there at top and the tensile stresses will be there at bottom. And during night, the tensile stresses are there at the top and compressive stresses will be there at bottom. Please draw this figure. Everyone, please draw this figure.
Yeah.
Okay. So this is the effect of the warping stresses on the top and the bottom fibers during the day and night. It is shown here. Okay. Then the based on the plate load theory, the Westergaard has given the formula for calculating the warping stresses as well. Okay. So in the 1938, the Bradbury modifies this formula and developed the following equations for calculating the maximum warping stresses at the interior edge and the slab having the finite dimensions. Okay, so they have given the formula for calculating the warping stresses as sigma t for the interior portion, edge portion, and for the bottom fibers, sorry, at the corner place. Okay, so at these three locations, they have given the formula for calculating the stresses. Then the second temperature stress is the frictional stresses. Okay, so see here in the figure, you can observe when there is the movement of slab are restrained by its self weight caused by the intersurfacing frictional force between the slab and the supporting layer, that may be the subbase layer. For example, when the slab contracts, its movement are restrained by the frictional force and tensile stresses will be developed. See here, you can observe in the slab, see here, the below is the subbase and above it is slab. So what will happen when there is fall in the temperature, the slab will tries to contract, but there is interlocking between the slab and the subbase layer. Okay, there is interlocking between the slab and subbase layer. So that what will happen, the slab will tries to go there, but the below surface subgrade surface is will not allow the movement of the slab. So due to this, what will happen, the frictional stress it is developed between these two layers. Okay, and it is calculated by using the formula sigma f is equal to WFL divided by 2 into 10 raised to 4. Okay, the frictional stresses are calculated by using formula sigma f is equal to WLF divided by 2 into 10 raised to 4. W is the weight, L is the length, F is the frictional factor. Okay, so by using this formula, we calculate the frictional stresses induced. Then what are the critical combinations? This is very important. Know the critical combinations of the loading. Means what? Suppose the load due to the temperature stresses is allowed, arrived, load at the interior due to the extra loading, at the edge places, at the corner places, stresses will be induced. Okay, if we take the combination of these all, what will be the critical combination of the stresses that are developed? So these are given here. Please see the cumulative effect of the different stresses give the rise in the following three critical conditions. If you take the cumulative different kind of the stresses and if we mix up it, then what will be the critical combinations of these cumulative stresses? So they have derived three critical combinations. The first one is in the summer and at midday. In the summer and midday, the critical stresses is for edge region is given by the formula sigma critical is equal to, please write down this formula or plus listen, the sigma critical value, critical force value, sigma critical is equal to sigma E plus sigma TE minus sigma F. Okay, in the winter midday, the critical combination of the stress is at the edge region and it is given by the formula sigma critical is equal to sigma E plus sigma TE plus sigma F. Okay, and at the midnight, it may be summer, it may be winter. In the summer as well as in the winter at midnight, The critical combination of stresses is at corner. Please keep in mind, for day it is at edge, and for winter as well as summer in the night it is at corner. The critical combination of the stresses is at the corner, and these are calculated by using formula sigma critical is equal to sigma C plus sigma Tc. C indicates at corner, T indicates temperature stresses, okay, thermal expansion, thermal stresses. F indicates frictional stresses, T indicates thermal stresses, and this is sigma at the edge, stresses due to the loading at edges. E indicates edge. Okay, please write down this formula and highlight the portion which I have highlighted. Okay, whatever the portion I have highlighted, you should also highlight that portion. Write down these three conditions. These conditions are the critical conditions due to the loads, temperature, thermal effect, and frictional effect. Okay, write down these conditions. These are very important. Draw this figure, everyone. Write all these conditions. These are very important conditions. Exam point of view, important conditions are there. Completed. If you complete, then we'll stop here only. Those who have not completed, write it. Those who have completed, mark your attendance to the chat box. If you have completed, mark your attendance in the chat box, then you can leave the lecture. Thank you for attending the lecture.